Hello, welcome to another episode of Yummy Data Science. In this episode, I will be walking you through analysis of inpatient for Viz CSV file. Recall that this file has been created from Medicare inpatient data. Uh, I've shown you that process in an earlier episode. And also in an earlier episode, I've shown you in RStudio how to create a project. And very quickly, a project in RStudio is a convenient way to group everything associated with an analytics program. Um, and this is Hadley Wickham, whose textbook we are following, R for Data Science. And this is his framework. You bring the data into R, then you analyze whether the data is tidy or it's in a format that is conducive to analysis. And then you start the process of understanding it. And understanding means you may have to transform the data, you're visualizing it, you're modeling it, and then you're communicating. But in this case, we are going to be importing it. We're going to be looking at the tidy aspect of the data. And then we're going to do very quick data transformations. This is not the focus of the video. The focus of the video is on visualizations. And you can see that I just fired up RStudio. I can go in here and I can open, and under Open Project, I will navigate to the directory that I created when I created my project, Public Health Class. Okay, and you can see that the way I've set up my tools and global options, you don't really see there is much of a difference. And that's because I have configured it not to save intermediate data sets. I've configured it not to save the workspace. So it comes up as a blank slate. Um, very brief refresher. This is the console. This is where R is running, not RStudio. And this is where when you write a script, you will see the results of the script coming over here. And this is the environment window. This is where you're going to see your objects popping up. And this is the file system. And you can see that because our project refers to the public health class, we are by default in that directory, and there's our inpatient for viz.csv file. And the file that we are interested in reading this CSV file. And I've already written a script, but I am going to go through it line by line. So I've written this script, which I can open from here by double clicking, or I can go to File and I can say Open File. And here I am going to open the script. The way that the script is named, it's module 3 because we are in module 3. And this is the first program of the module 3. And the program is called Basic Data Transformation and Visualization .r. Okay. So we've talked a little bit about the Tidyverse library, but not much. Let me just say that this is the library. It's a super library. It has many packages inside it. And this is a library that was created by Hadley Wickham. He is the author of it. It's absolutely brilliant the way that the various components talk to each other. So I'm going to there are many ways of running it, and you will see people have shortcuts and so forth, but I'm going to do it in the most obvious but perhaps not the most efficient way, which is I'm going to highlight code and then I'm going to hit the run button. Okay, and it basically says run the current line or selection, and it also tells me that I could do that if I did control enter, but I'm going to do run here. Okay. So you can see it ran the first line, and at the very bottom, it's telling me what it has done. So the Tidyverse library has many packages in it. We will be using Dplyr to transform our data, and we will using ggplot2 to visualize it. Okay. The focus of this video is on ggplot2. However, we will need to use Dplyr to do some basic data transformations. So we're going to be using it. And for the purpose of this demo, let's just take the data transformation at face value, because in the next module, we'll be focusing on the data transformation pieces. So I'll explain a little bit, but we're going to go through it quickly. And this is an okay approach if you're new to a programming language. It's okay to say, well, I understand this syntax maybe about 30-40%, but I have it from a verified source, and I'm focusing on understanding something else. So I'm going to take this segment and go with it. And a good goal when you are learning to program is to take other people's good syntax, good readable syntax, tweak it and use it. So just like you're learning a new language, you can say, okay, here are some phrases. I don't completely understand how they're put together, but I'm just going to learn it. And then I'm going to focus on maybe the present tense. So the present tense in our case is ggplot2. And the phrases that we are memorizing or sort of learning are the Dplyr library, which is transforming the data. So now I'm going to run line 3. And line 3 is saying, create me a table. A table is a data set or a table. And for those of you who do know RStudio, there is a concept of a data frame in RStudio, and a table is slightly different, but it's mostly the same. So create me a table, and how? Well, use the read CSV function, a read CSV function, and you'll see when I hover over it, it tells me the syntax. So RStudio gives you that help, and it also does some suggestions and completions. And if yours isn't doing it, then you would go under Tools and look at global options. I won't get too much into this, but you can go into Tools and global options. Okay, so back to line 3. This is an assignment operator, and it's basically an arrow that is facing left. This is saying read inpatient for viz.csv using the read underscore CSV function and put it in a table called Inpatient. So let's just do that. Pressing run. So here we go. Now this is telling us that there are, oh, by the way, I forgot to explain why you see these conflicts when we ran the library Tidyverse line. So it is basically telling you that the filter function conflicts with the filter function in the stats package. That's what the red X's mean. And that's good to know. So if you were to use Dplyr and the stats packages together, then you would explicitly, and you were to use filter from both, you would explicitly state which package it comes from. Okay, that's what that message is. And you can suppress it, but for right now, I'm not going to suppress it. So this is telling me that this table had 191 rows and 8 columns. And here are my columns. It figured out what delimiter it was. So it figured out it had a comma separated. And it told me that the description was read in as a character, but everything else was read in as double, which is a way of storing numeric data. Now, if you recall, beneficiary ID, claim ID, they should not be read in as numeric. These are patient and claim identifying information and should always be read in as a character. And why is that? Because it doesn't make sense to do a mean of beneficiary ID or a mean of a claim ID. Length of stay is a number. So that's okay for it to be in a numeric format. So is amount. Amount is the charge amount. And the patient discharge status code, that's a code. So it's like a 1, 2, 3. R has a data type called factors. So you could think of it as a factor. 1 is separate from 2, is separate from 3, etc. And then DRG is a healthcare code. And DRG is a combination of diagnosis. DRG reads diagnosis related group, and it's a combination of diagnosis, treatment, and resource used in that hospital stay. But for right now, we're going to consider DRG as the diagnosis information. So one of the first things you'll notice is that some of the data types that it read automatically are not what we want it to be. And there is an elegant way of doing it right in as you're reading the data, but I'm going to show you a simple but perhaps not the most programmatically kosher way of doing it. So, and that is done right here in lines 5 through 9. And you'll see there is, I'm going to call this is a pipe character right here. Okay. And you can see that I've painstakingly lined it up. And when it comes to programming, writing code, it really helps to be a little bit OCD. Imagine if these were scattered all the way. Now, with the pipe, think of it, we'll get into that a little bit more later on, but think about it like, then do this. That's what the pipe means. So this is saying, take the inpatient data, the table that you made, now put it in another table called inpatient. So you're overriding the data. And you might think about, well, is this really a kosher thing to do? Yes and no. And I'm just going to go ahead and rewrite my existing table. So that's line 5. And then it says, okay, take the inpatient table, put it in another table called inpatient. So rewrite the whole thing. And then, all right, transform BenAID. So Dplyr is just a very elegant package, and it reads much like English. So this is saying take BenAID and now transform it in place and read BenAID as a character. That's all. Same thing with the claim ID. And the pipe here this is referred to as a pipe. And again, if this doesn't work, look at your tools, global options, and here there's a check mark, use native pipe operator. So check this one if it is not checked. So then we read both BenAID, claim ID as characters, we read DRG as character, and then we did the patient discharge code as a character, the claim IP admission type code is a character. Now, I don't really like the naming convention. Patient discharge status code is just too long. So I'm going to use the rename command to rename. And the syntax of the rename is new name equal to old name. Very simple. Same thing with admission. And then what I'm doing here is mutate command says, okay, now I want to mutate, I want to create a new column. And I'm creating a new column called DRG description. And that is the concatenation So pasting, you're taking DRG, you're taking descriptions, and you're gluing it together. You're pasting it together. And what are you putting in the middle as a glue? You're putting the separator. Got it? Now, if I can do two things, in order to see the inpatient data set, I can double click on this, and you will see that now it has been read incorrectly, and I have DRG description. I'm going to X out of that. Now, double clicking on a data in the environment, if your data is very big, it might even crash your RStudio session. So what Tibble allows you to do is it allows you to glimpse that inpatient. And let me show you what that looks like. So here we are glimpsing it. We're looking at it. So it has these rows, these columns, and then it has a very short, handy thing. It will tell me Bene ID is a character, and it will give me the first few values. So here you can see that instead of double clicking, you could simply look at that. Now, what I'd like to know is I see DRGs 864, 203, and so forth. What I'd like to know, I'd like to have a sense of where the volume is in my data. And I know that this is about the length of stay, the charge amounts for hospital discharges. And I have a diagnosis information, but I want to know where the data is. So I want to know by each DRG and by each DRG description, because it'd be nice to know, in addition to the code, what it actually means. I want to know how many counts there are, how many discharges per 864, fever and inflammatory conditions. So you can see that now I am doing the Dplyr package, and now I'm saying take inpatient and then group it by DRG description. So basically, group by means that I'm getting ready to ask for a summary statistic. And what's the summary statistic? It's the N. And what am I going to call? N simply means the number, the row count. And count is the column that I'm going to call N. So for those of you who know SQL, this will seem really familiar. But the notion is that whenever you ask for a summary statistic, you have to say summary of what? By what? So income by age, income by educational status. So, and then when you say by, think group by. So if I do this and run, you will see that in the output below, and by the way, you can notice that I'm not creating another table here. I'm just saying I'm not creating an object here. You can see I still have only one object in here. I'm not creating an object. I'm just looking at the output in the console window. Okay. And I can see that 182 DRG, the respiratory neoplasms without CC. Neoplasm is another word for cancer. So that has 78 rows. So 78 discharges. And what I want to do is I want to say, okay, I'm going to plot my the bulk of my data. And so I'm going to take 78, these guys, and I'm going to take the next one is 24. I'm going to take respiratory signs and symptoms. And my a priori hypothesis is that the amount increases with the length of stay. The amount charged for a hospital stay increases with the length of stay. So if you stayed for 4 days and you had X amount, and then you stayed for 8 days, then you might have 2X. So that's my hypothesis. That's my a priori belief. And in my visualizations, I'm going to test out that hypothesis. Um, and I will do it for only two DRGs, so 182 and 204. And up here, what I'm doing is I'm saying overwrite inpatient. Now, remember, this is a decision I'm taking to overwrite my original table. This may not be the wisest idea if this were a very large data set, but it's a common practice. So I'm overwriting my inpatient table. I'm using the pipe and I'm saying filter. Filter is another one of the Dplyr commands, which says, okay, DRG in. So this funny looking in means that it is in either of the following. Okay. C means if we're giving it a list. So it could be that if the DRG is in 182 or the DRG is in 204, then we're going to filter that row. That's all that this is telling us. So we filtered for that. And now you can see we began with 191 rows and now we have 102 rows. So now let's learn, having learned the phrases of Dplyr and how to read in a file, the read CSV function. Like I said, I've just thrown that at you without too much explanation of Dplyr. But now let's learn the grammar of ggplot. Okay, so here I'm invoking ggplot and I am giving it the data inpatient. So let's see what happens. Well, this turned gray, which is good, but nothing has happened. And that's because ggplot is awaiting further instructions. ggplot is saying, okay, fine, you gave me the data, but you haven't told me what to do with it yet. Okay, so in my next command, in my next set of command, I'm going to build on the previous set. I'm going to give it the mapping argument. So I will need to tell it. I'm going to need to give ggplot a mapping of my columns to ggplot. Okay, and what I'm saying is that in my x in my x dimension, I want to put LOS. Okay, in my y, I want to put the amount. So if you're thinking ahead, you're probably thinking that this is going to be a x-axis and a y-axis, and y-axis is going to have the amount and x-axis is going to have the length of stay. So now let's see what's happened. Oh, good. So it now made it a grid and it put the amount in scientific notation and it put the length of stay. And at the very end, I'll show you how to get rid of the scientific notation because not all of us can learn to, this is very difficult to interpret. So, okay, we got the mapping, but we haven't done anything. We haven't plotted anything. So that comes with the next line. And notice how I have a plus sign. So I gave these arguments to ggplot. I told it what data it needed to read in. I told it what the mapping would be. And now I'm saying, well, what kind of a graph or an object, visualization object do I want? What kind of a geometrical object do I want? And I want a point or a scatter point. So I'm saying geom point. That's what I want. Now I'm getting something that looks like a scatter plot. And you'll see that each inpatient stay is denoted by a dot. And if you look over here, this seems to be a bit of an outlier. And let's talk more about this later on. Well, wouldn't it be nice to know which of these dots correspond to which of our two DRGs that we selected? Indeed, we can do that. By putting it on a color dimension, we put DRG. So that goes in the mapping, and we are putting in the color dimension, we are giving it the DRG. So here, if you run that, this is interesting. So now you can see what a nice relationship there is for 182 and 204 also, but bulk of the data is right here. Okay. So what else can we do? I know I said we weren't going to model the data, but let's do it. Let's create a linear regression. And for those of you who don't know what a linear regression is, don't worry about the fancy word linear regression. Just think about it, a line that goes through the data that fits the data as closely as possible. Okay, that's what it is. And if we just had 2 points, it would be a line that fits both points. I mean, that's the definition of a so the way you can do that is you can say, okay, geom underscore smooth, and method is LM, linear models or linear regression. So let's do that. This is lovely. So this is the linear regression line. Now I have a question, and this is going to be an exercise. What impact is this outlier doing to the linear regression line? If we removed this row, how would the slope of this line change? And how does the linear regression line help us? Well, it shows us the relationship between amount and length of stay. If length of stay increases by 1, then amount increases by x. And you can see this slope is steeper. Okay. And the way I like to think about it is, if you're not mathematically inclined, you can think I'm running up a hill. Which hill is easier for me to run up on? Is it this one or it's this one? Well, it's clearly this one. So this one, it's less steep. The hill is less steep. And this one, the hill is pretty steep. So that means with 1 unit increase in length of stay, I'm going to go quite far up the hill for DRG 182. So the amount will increase more than it would for DRG 204. And it illustrates the differences between the two, between the relationship between amount and length of stay for these two DRGs. And in the next ggplot invocation, what I'm showing you is that I am taking, these are 2 separate lines, which seems very appropriate. But what if I wanted just 1 line? And so then I would remove the color from the mapping and I would put it in the geom plot. So then the geom smooth looks at the mapping. You see, the mapping is the primary source that it's looking at. And by squeezing in the color dimension here, we have sort of tricked the geom smooth to do only 1 line rather than 2. So let's see the impact of this. And you can see that this line is for both the DRGs together. And I don't quite like it as much as I like the separate lines because there's clearly DRG is the differentiator between the two. Remember I said that I don't like the scientific notation. So in the next ggplot, I'm going to show you how to get rid of the scientific notation. And it's a little bit trickier than is explainable in the first session. So I'm going to say, please take it on face value that this code does what it does. it did require me to install another library called Scales. And that is what I'm doing here with scale y continuous. And I'm saying make it a dollar and do divide the scale by 1,000 so that it's in per 1,000. And then the other thing I've added in is I've added labels. I've added a title, subtitle, and cleaned this up a little bit. So here you go. So in this plot, we have a nice title, what determines hospital inpatient amount charged, length of stay and diagnosis. And then we have a y-axis label, x-axis label, and you can clearly see that there are the relationship is quite different for 182 versus 204. And 182 was the neoplasms. So it makes sense. Neoplasm is cancer. It makes sense that the amount charged is going to be higher than respiratory symptoms and problems. So as an exercise, I'm going to suggest that you identify and remove this outlier, redo the visualization, and think about what happens to the slope of this line. I actually haven't tried it, so I don't know what might happen. So it would be good for you to try it. And then the second thing is to create the visualizations by amount and LOS for each value of DRG. To think more deeply about what determines amount and why. Thank you for listening.